class, Algebra 2 Trig. This is section 1 of chapter 1, Parent Functions and Transformations. Okay, let's see. Here we go. Okay, so for this section, actually there's quite a bit in here. We have a couple goals. Let me see if I can make this go away. Okay, couple goals. The first one is to understand what the parent graphs are going to look like for some very specific functions. So your constant function, meaning a horizontal line, as well as any kind of linear function, absolute values, and quadratic functions, meaning parabolas. The second goal then is to start working with these transformations. That's the hard part that we need to practice. So first of all, just to make sure, we've been using the term parent graph, and I want to make sure everybody kind of has an idea what I'm talking about. So a lot of times you have functions that all kind of generally look the same, that are in the same family. They share certain key features, like for example, where their turning points are, meaning like their mins and maxes, or the same power of the variable, like quadratic equations all generally look the same. They're all parabolas. So we have a parent graph, which is kind of the most basic equation that's in that family. Okay. So here are the parent graphs of these types of families. So constant functions are horizontal lines. It's where you have basically y equals a number. So y equals 3 is a horizontal line at a height of 3. Linear functions, well, if you strip away the m and the b in y equals mx plus b, you just have y equals x. So your basic parent graph is just the equation of the line y equals x. Absolute value would be y equals absolute value of x. It's our V shape. And finally, the parabola, if it's just x squared, no other numbers over there, then it's just our parent graph sitting at the origin, opening up. So for each of these, you should be comfortable listing out your domain and range. So on your notes, please go ahead and fill those in. I'll just kind of walk my way through it there. You can fill them in as I talk. So for your constant function, the domain is all real numbers, but your range only has that one y coordinate, which is 3. So domain is all reals, range y equals 3. For the linear function shown here, the domain's all real numbers and the range is all real numbers. It goes up forever and down forever. It goes right forever and left forever. So for absolute value, the domain, since it goes right and left in both directions forever, it's all real numbers for domain. But your range is only the values that are positive or 0. So you'd say y is greater than or equal to 0 for the range. Quadratic function, domain, again, all real numbers, and the range, again, it's going to be y greater than or equal to 0. So these are our parent graphs and their domains and ranges that you should have memorized without, any kind of time going by. If I say, what does it look like, you should be able to draw these, no problem. So once you have those down, then we can start practicing the transformations. And here I've listed out kind of the 4 bullets listed on the slide are the types of translations that we're going to be practicing. And, excuse me, I put on the top of the slide there that, don't feel bad if it doesn't make sense to you perfectly right away. We need to practice this quite a bit, most people do, in order to really feel like they understand it. So that first bullet point there, translation, means basically you're shifting the graph up or down or right or left. That means you're not stretching it or shrinking it. You're kind of preserving its size and shape, if you will, and you're just picking it up and sliding it and putting it back down on the paper. A reflection is where you're flipping it over, and specifically over the x-axis or over the y-axis. And then we have ones where we are actually going to be stretching them or shrinking them, either in the vertical direction or horizontal direction. And those ones definitely, the shape of the graph changes. It's no longer going to be congruent to the original parent graph. So what we'll do is basically take each one of these bullet points and go through some examples so you get an idea what we're talking about. So the first one was translations, and we'll start with shifting it up or down. I'll just go straight to my equation for the example 1. It says y equals x squared minus 2. So again, I know it's in the family of quadratics, which is y equals x squared. So my first picture on the left there just has the basic parent graph of a parabola. Then the minus 2 on the end, I know is going to shift it down 2. Well, that's the new part. That's what you're supposed to be learning. So it's y equals, and then instead of just being x squared, it's 2 less than x squared. So the y equals 2 less than it did before. It has to be shifting it down by 2. Okay, so we get our new picture, which is basically the first picture just slid down 2. So in summary, if you want to slide a graph up or down, you need to either add or subtract a number on the end of the equation. So if you want to slide the graph up or shift it up, you're going to add a number on the end, or if you're going to move it down, you're going to subtract a number on the end. This is probably the easiest of all of our transformations, is the up and down translation. Okay, what about if we want to shift the graph right or left? And again, we're not going to be changing its shape or size. It's still going to be congruent to the parent graph. We're just kind of moving the whole thing over, right or left. So if you look at the equation, given in example 2, there's a plus 2 in there, but it's inside the parentheses before you square it. So the input is really being affected, right? So whatever x was, I'm adding 2 to that. That's the input value into the function. I'm adding 2 to it before I square it. So my output is not necessarily directly well, it is changing, but it's the input really that we've altered, not the output so much. If that makes sense. So quadratic family, again, is still a parabola, but this time we're moving it to the left by 2. So again, the x plus 2 inside the parentheses actually goes left 2. Seems a little confusing because you're replacing x with x plus 2. You'd think it would move to the right, but when it's in the parentheses like that, it's actually backwards from what would make sense. It goes left 2. If you wanted to understand why that's moving left, not right, you can think of plugging in a value for x and actually seeing where it ends up. So I'll let you try that on your own if you want to take time to do that. So in summary, when you're moving right or left, again, if I'm using my function g of x as my new function and f as my parent graph, so I would take my parent graph and whatever x was, I'm replacing it with x minus c to get it to move to the right. And I'm replacing x with x plus c if I want it to move to the left. Okay, and I put a little note there on the bottom as we're going through these translations. Keep in mind that all of these things that we're learning apply to all functions, all families of functions, not just quadratics. So you can apply it to, cubics or, lines even, whatever it is that you're studying. Okay, let's do some reflections. So these are going to be flips. So first of all, if we want to flip it over the x-axis, then we need to put the minus sign out in front of the equation. So we have y equals, and then you're going to put a minus sign out in front, and then the equation, absolute value of x. So I know my parent graph is just y equals absolute value of x, which is the v opening up, sitting at the origin. The slope on the right is 1, the slope on the left is minus 1 of our two pieces of the v. Okay, so you put a minus sign out in front of the entire equation, it simply flips it over the x-axis because now y is always equal to something that is negative. Because negative of absolute value means absolute value is a positive. So you have a negative of a positive number is negative. So it's got to be y values that are at the bottom below the x-axis. Okay, so here's our summary. Just putting a minus sign out in front of the equation flips it over the x-axis. What about flipping over the y-axis? Okay, well this time if you put the minus sign inside the absolute values in front of the x, that's going to flip it over the y-axis. I like to think of it as replacing my variable with the negative of my variable. Okay, and that will flip it over the y-axis. So for this particular function, absolute value of x, if I flip it over the y-axis, I end up with exactly the same picture as I started with. Obviously, that's not always the case, but I thought I'd put it in here just to point out that absolute value of x is already symmetrical across the y-axis. So if you flip it across your line of symmetry, it's going to look the same. Okay. Also, by the way, I put in at the bottom with my note there that this is considered an even function because it's symmetrical across the y-axis. Okay, so in summary, if I'm flipping it over the y-axis, I want to be thinking of replacing my variable with the negative of the variable. So x, instead of using x, I use negative x, and that will flip it over y. Oh, sorry, I think I went the wrong way. Okay, Moving on, let's do the stretching and shrinking vertically first. So this example, I have y equals 2 times x squared. So again, x squared is my parent graph, my parabola sitting at the origin opening up. If I throw a 2 out in front, now we are stretching the graph vertically by a factor of 2. So in my parent graph, instead of going through the point 1, 1, okay, now it needs to be going through the point 1, 2. Okay, so as you're looking at the pictures, make sure you're paying close attention to the scale. So the picture on the left, every 2 boxes is 1 unit, same as on the right. Okay, so over 1 up 1 in the first graph, whereas the second graph is over 1 up 2. Okay, stretched by a factor of 2. So in general, for our summary on this one, oh, actually, first I did a second example of shrinking. Okay, so y equals a half of x squared. So on this one, instead of going over 1 up 1, we go over 1 up a half. So vertically compressing it or shrinking it by a factor of a half. So now here's my summary. So if you're multiplying by a number that's larger than 1, it's going to stretch it vertically. If you're multiplying by a number less than 1, it's going to compress it or shrink it vertically. And again, the general form of the equation is you're just multiplying some number a out in front of your function. Horizontal stretching and shrinking. So this one, you're still multiplying your variable by a number, but you're doing the multiplication at the start, like you're replacing the variable with twice the variable is the way I think of it, as opposed to multiplying kind of the output by 2 on the last one we did. So again, for my example, it's 2x quantity squared, which if you simplified would be 4x squared. But if you think of it as 2x quantity squared, you could say this is a horizontal compression by a factor of a half. So that 2 out in front, instead of thinking of it as horizontally stretching it factor of 2, whenever it's inside the parentheses, a horizontal effect, it's always backwards from what you're thinking. So inside the parentheses, you see a 2, it's actually going to be the reciprocal of 2, which is a half. So we're multiplying by a factor of a half, which is going to be a horizontal compression. So again, in my parent graph on the left side there, you notice it goes through the point 1, 1, again, paying attention to scale. Whereas my new graph, it's going to go over a half before it goes up 1. So it's horizontally compressing it. Okay, so again, my first graph went through 1, 1. This graph goes through a half 1. Okay, so the x-coordinate is changing when you're horizontally compressing it. Now, by the way, on this one, if you did choose to rewrite it as y equals 4x squared, then that 4 out in front would actually look like a vertical stretch by a factor of 4, which if you compare it to my second graph there, if you were to pick stretching our parent graph by a factor of 4 vertically, you know, the graphs match up. So it's kind of a matter of how you're looking at it. So the way it's written, y equals 2x quantity squared, the 2 right in front of the x there, that's a horizontal compression of a half. But again, if you were to multiply it out, so y equals 4x squared, the 4 then would become a vertical stretch factor of 4. And whether you do a horizontal compression factor of 2 or a vertical stretch factor of 4, it comes out the same. They look identical. So here's my 1/2 out in front of x. So again, I'm altering the input is the way it's written. So because it's a 1/2, again, horizontal, everything's backwards, so the reciprocal of a half is 2. So it's going to look like a horizontal stretch factor of 2. So compare my two graphs there, going over 1 up 1. Now I need to go over 2 before I go up 1. So multiplying horizontally, the x-coordinate is changing. Again, if I were to square it first, just to simplify it, y equals a fourth of x squared, then it would look like a vertical compression by a factor of a fourth. So now if you go back and look at the picture, if I go over 1 up a fourth, that looks about right. Keep in mind our scale here on the y-axis and x-axis. So here's our summary for the horizontal effects, stretching and shrinking. So if you're multiplying the variable by a number, replacing the variable with the variable times a number, and that number happens to be bigger than 1, it's going to shrink it. A number less than 1 is going to stretch it, which sounds backwards, but that's just the way it is. So again, in our equation, our g of x would equal f of b times x, and it depends whether b is a number bigger than 1 or less than 1, whether it stretches it or shrinks it. Okay, so here, putting it all together, I decided just to make the most complicated equation possible. Okay, it doesn't get any worse than this. And if you're looking at the equation this way, and you know what the a, b, c, and d do, then you can handle whatever kind of stretches, shrinks, flips, shifts, whatever. So in this long equation here, g of x equals, again, the a out in front, if you're multiplying by a number out in front, that is our vertical stretch or shrink, depending on whether a is a number bigger than 1 or not. And then the b value is our horizontal stretch or shrink. And again, it's going to stretch it when b is a number smaller than 1, and it will shrink it when it's a number bigger than 1. Replacing x with x minus c, that's a horizontal shift. And again, because it's still inside the parentheses affecting the input, it's kind of backwards from what you would be thinking. So x minus c is going to shift it right. If it was x plus c, it would shift it left. And then finally, the d on the end there is just our vertical shift up or down, just the way you think it would be. Adding a number shifts it up, subtracting a number shifts it down. So the only thing missing there then would be the flipping it over either the x-axis or y-axis. So if that coefficient a out in front actually is a negative number out in front, that's going to flip it over the x-axis. Whereas inside the equation on the input, if x is replaced with negative x, we would be flipping it over the y. And again, that really is the b value, the coefficient of x, that would need to be negative to flip it over the y-axis. Okay, I hope all this makes sense. This was really quick going through. I'm sure you're not thinking it was quick, but I was talking fast, so I feel like it was quick. Anyway, there are 4 problems now for you to try. I'm asking that you graph them on paper and double check that your answer is right. And again, I would suggest you pause right now because I'll go over the answers in just a second, but go ahead and hit pause for me. Okay, so the first one, y equals x plus 1. What I will do is I'm going to go to my online graphing calculator, Desmos. I don't know if you've tried this one before, but it's DESMOS. You click the red button that says Launch Calculator. It takes a second to load it. This is my favorite online graphing program. Okay, so over here on the left side, you're going to type in the equation, which was y equals, now I've forgotten. Let me switch back and read it one more time. PowerPoint. What was it? X plus 1. Okay. Sorry about that. So y equals x plus 1. And as soon as you type it in, voila. And click over here, you can see a graph. Okay, and check your work. Make sure you're doing it okay. So if you go back to the other ones, so y equals negative x squared, you would just type that in. You can do this squared with the up arrow key. So let's go back to that, y equals negative x squared. So let me just clear this one out. And I type in negative x squared. So x up arrow and squared. Oops. Sorry, I'm a little slow. Oh, for some reason it did a subscript. Can't see what I'm doing. There we go, up arrow squared. Okay, and as soon as you type it in, again, you can see it right away. If you want to do absolute values, right here, down at the bottom, you see absolute value of A, you can enter it that way. So go ahead and check your work on Desmos, or if you have a graphing calculator, or any way you can check your answers on some sort of utility. Go ahead and do that, and I will see you tomorrow. That was it. Thanks, you guys.